and welcome back, all my wonderful grade 10 learners out there in South Africa and beyond. Thank you so much for tuning in, and thank you for watching my videos. I really appreciate it. Thank you for all the wonderful comments I'm receiving. I really, it makes my heart warm to see all these wonderful comments. I really appreciate it. All right, so we've been on a month-long holiday and now we're back. And with my grade 10s, we've started function notations and graphs. So you take a function and that function you can redraw into a graph. And this is a formal assessment that we've written, which I thought was quite comprehensive questions on all the function notation as well as straight line graphs. So at our school, we already start the straight line graph in grade 8 to start drawing it, to see what you get. And basically, when we start in grade 8, we always teach you the table method. Okay, so with any function, you have an input value and an output value. So if x is 1, what would your y value be? If x is 2, what would your y value be? Now, when we get to grade 10, we just write it in a little bit more formal. Okay, so it's a little bit higher grade, it's grade 10 level, and this is what we call function notation. So basically, if I ask you to calculate f of 2, it means that what was the original? It was f of x. And we all know that that is your y value, f of x. Even if you punch it into your calculator in your table method, it will give you the x value as well as the f of x value. And we know that f of x is actually just equal to y. And now they say to you, from f of x, this is the original. There it is. Change it now or simplify so that we can find f of 2. So what it basically means is, if I make all the x's 2, what would my y value be? All right, so it's easy as that. So f of 2 is equal to, and everywhere where you see an x, you replace it with a 2. Okay, always please within brackets. So that would be -4 plus 8, and that would give you 4. So f of 2, the y value then will, if you've replaced all the x's with a 2, the corresponding y value would be 4. Hope it makes sense, and it's actually quite easy. All right, and now as well, instead of just having a value, we ask you to replace it with 3x. So what was the original? F of x. So the x changed into a 3x. So everywhere where you see an x, you're going to replace it now with 3x. Okay, so f of 3x would be equal to -3x squared plus 4 times 3x. And then you just need to simplify. Please remember, everything inside the bracket is to the power 2. That negative is on the outside. His multiplication, he's going to, that order of operation is going to happen lastly. So 3 to the power 2 is 9, and x to the power 2 is x squared. Plus 4 times 3 is 12x. And that is your simplified form. You can't go any further because they're not like terms. Now, so with this one, there is your f of x. Now they say to you, place a negative in front of your whole f of x. So this whole expression here, so negative f of x will look like this. So a negative in front of the whole expression over there, which is -x squared plus 4x. Okay, so negative f of x is equal to a positive x squared minus 4x. Okay, and we'll get to the meaning of that. What if I just put a negative in front of the x, or what if I put a negative in front of the whole f of x? We'll get to that, and I'll explain it very nicely now. With these ones, can you see that f of x is over here? And now, instead of f of x, it's f of x plus 2. So everywhere you see an x, you have to replace it with x plus 2. So I always say, if you struggle with these ones, start in the middle, and then afterwards you multiply with 5, and then you add 2. All right, because it's 5 times the f of x plus 2 graph plus 2. All right, so let's start with that. So negative x squared, so f of x plus 2 is negative, and then x squared is now x plus 2 squared. And then, don't know why does it want to move, sorry, plus 4x. So plus 4, and the x must change into a x plus 2. Okay, so this will equal to negative, and remember this is not an exponent law where everything inside the bracket is to the power 2. You have to double up the bracket because there's 2 terms inside the bracket, plus 4x plus 8. Okay, and then I'm first going to FOIL out before I bring in the negative, which will give me x squared plus 2x plus another 2x is plus 4x, and plus 2 times 2 is 4, plus 4x plus 8. Now I can bring in my negative, minus 4x minus 4 plus 4x plus 8. And let's quickly see, can you see the negative 4x and the plus 4x can cancel out, it becomes 0, and negative 4 plus 8 gives me negative x squared plus 4. All right, now we can go and say, let's multiply our answer. So 5 of f of x plus 2 plus 2 will be 5 times negative x squared plus 4. And then we have to add a 2 at the end. And that will give me negative 5x squared plus 20 plus 2, which will give you negative 5x squared plus 22. Number E. Let me just get a nice different color here. Okay, so now they say to determine A if f of A minus 1 is equal to 0. So let's look at the function. How did it change from f of x to being f of A minus 1? So what do I need to replace the x with? A minus 1. So let's do that. So negative x squared. So f of A minus 1 would be negative x squared plus 4x, sorry. And then everywhere where you see an x, it must change into a minus 1. Again, take the negative, weights on the outside. I'm just going to do this the quick way. A squared is a squared. 1 times negative a is negative a, times 2 is negative 2a, and a negative 1 squared is a plus 1, plus 4a minus 4, which gives you negative a squared plus 2a minus 1 plus 4a minus 4. If I simplify that even further, I get negative a squared plus 2a plus another 4a is plus 6a, and minus 1 minus another 4 is minus 5. But now they're telling me that I must equal this to 0. And hopefully you can remember your trinomial rules and how to factorize a trinomial. If you want to, you can take out a negative, or you can just throw them all over to the other side to make it a positive a squared that we start with. And that is a trinomial. The a splits. The signs are both the same. What are they the same of? They're both negative. Let me just erase that so it doesn't look confusing. And what times what gives you 5? And if you add or subtract gives you 6. 5 times 1, because minus 5 minus another 1 gives you a negative 6. And if you multiply the 2, you get positive 5. Thus, a is equal to 5. or a is equal to 1. Voila. Let's look at question 2. Okay, then question 2, the following two functions are given, h of x and k of x. So remember h, k, l, doo-doo, mama. It's just a name of a graph. So we just use any alphabet letter to represent that function. Okay, so now they say to determine h of 2 plus k of 24. So h of 2, which means for every x value, we need to go and replace it with a 2. Okay, so 2 times 2 plus 2 over 2 minus 1, and then I need to add it to k24. So over here, the x must become a 24, which will then give you 2 times 2 is 4, 5, 6 over 1, plus 24 plus 1 is 25, and the square root of 25 is 5. So your answer is 11. Okay, now they say to determine x if h of x is 1. So h of x, so it must stay h of x. All they are saying is equal it now to 1. Okay, so whenever you've got a fraction, you multiply with that numerator on both, the denominator on both sides. So you get 2x plus 2 is equal to 1 times x minus 1, which gives you 2x plus 2 is equal to x minus 1. 2x minus x is x, and negative 1 minus another 2 gives you negative 3. And there's your answer. Now they ask you for which values of x is h of x undefined. So if we clean up here a little bit, they say to you, where is this going to be undefined? Remember, what does undefined mean? It means when the 0 is under the line. How can I make this expression that the denominator becomes a 0? So x minus 1 must be 0. So x should be 1. And you can test yourself. 1 minus 1 is 0. So to make it undefined, x must be equal to 1. Hope that makes sense. Now they say to you for which possible values of x could form part of the domain of k. So if you look at k over here, now what could form part of the x's value? What values must x be to make it a true value or to make it a possible value? So we know that we can't have a negative under a square root. Okay, so how does this x plus 1 become a negative? So x plus 1, how does it become a negative? So can you see if you throw it over, x plus 1, if you equal it to 0, you will see that x is equal to negative 1. But now, so if you've got negative 1 plus 1, the square root of 0 is still fine because the square root of 0 is 0. It's as soon as it becomes smaller than negative 1 that it will be not a possible answer. So let's just quickly see. So if we have the square root of, let's say, negative 2 plus 1, will it give me a negative? Yes, it does. Sorry, not the negative there, the negative over there. Negative 2 plus 1 still gives me a negative. If I have the square root of negative 1 plus 1, that's still fine because the square root of 0 is fine. So x must be bigger than or equal to negative 1 to give me possible answers for the domain for the x's value. Okay, I hope that makes sense. A little bit of a higher order question. So just check if you've got negative 1 plus 1, it's still fine. But as soon as negative 1 becomes smaller, like negative 2, negative 3, then it becomes a negative under the square root. So x, to make the possible values is x must be bigger or equal to -1. Right, question 3. So graph h of x is equal to x plus 2 is given. Explain in words the difference between the two functions and then calculate the equation of the following two graphs. Okay, so what does it mean when the negative is inside the function or when the negative is outside of the whole function? So over here, do you agree? Only the x must change. So what that means is, remember, if it's a reflection upon the y-axis, the x must change, and if it's a reflection upon the x-axis, the y must change. There's always the opposite. So only the x must change. That means that it was a reflection about the opposite to x is y-axis. Okay, and over here, if the whole function changes, that means it's the whole of the y function must change. Okay, so what it means is that the sign changes. I hope you understand it when I talk like that, sorry. So the whole y function must change. So this must be a reflection about the x-axis. Okay, so if it's a reflection upon the x-axis, the whole of the y must change. What is y? The whole h of x. And if it's just the x changes, that means it's a reflection upon the y-axis. Okay, and then they also asked me just to calculate it. So f of negative x will be equal to negative x plus 2, whereas here, negative h of x will look like this, negative x minus 2. So can you see it? Only the x becomes a negative or changes its signs from a positive to a negative. And over here, if the negative is outside the whole function, it means that it's a reflection upon the x-axis, which means both of these signs will change, negative x minus 2. Okay, that's a very good question, a very higher order question. So please have a look at that and understand. Now they say to you, now we're getting to straight line graphs. So this straight line graph is represented by 6y minus 24 is equal to 3x. So please remember, we always want it in the cookie cutter mold of y is equal to mx plus c. So let's get the 6y alone. And then we don't want 6y, so we're going to divide with 6 all throughout. Please, with an equation, if you do something to the one, it must be all throughout. So y is equal to a half x plus 4. Okay, so what we do know is that it's going to cut through over there at 4, and because I've got no grid lines, you have to indicate your coordinates, which would be there. And then, so we've got the y-intercept. So now for the x-intercepts, we're going to make, or the x-intercept, we're going to make y 0. Half x, divide with a half, and you'll get x is negative 8. So somewhere over here. And then just please with a ruler, I don't have a ruler now. So there's your straight line, and just call it, they didn't call it anything, so I'm just going to write y is equal to a half x plus 4 over there. Full marks. So for this one it was 3 marks. So if you had to allocate the marks, it would be in your coordinate, and reshuffling it in the cookie cutter mold. I always talk like that, the cookie cutter mold, which means it's in the original format of y is equal to. Okay, all right, sorry for the sniffing. Okay, consider the following diagram below and match each equation to its corresponding graph. Okay, so over here, this number D is that special line, so it's somewhere where y is equal to a number. So that D will go over there. These ones, can you see, sort of run parallel to each other. So they'll have the same gradient where this one cuts through the origin. So it would be y is equal to x is for C, and number B, it's the same gradient. So can you see a 1 and a 1 in front? But now it's been lifted up with 2. So this one would be B. And the last one, can you see it cuts through the highest point, which it does. And it's got the steeper slope than the y is equal to x. So this one is definitely A. Okay, so by order of elimination, or however you want to see it, that's a nice question to ask. Okay, study the 3 straight line graphs on the Cartesian plane. The equation of line CD is y is equal to 3 over 5x plus 3. And then they say to you line AB is parallel to the y-axis. Okay, so this one runs parallel to the y-axis. Let's do that a bit nicer. And line EF is perpendicular as indicated over there. Now they say to determine the coordinates of the points where line CD intersects with the x and the y-axis. All right, so we've got the equation y is equal to 3 over 5x plus 3. So this coordinate, you can see, is the y-intercept. Okay, so we know that the y-intercept is going to be 0, 3 without even a calculation. But now for the x-intercept, we have to make y. Can you see there is where the y is? 0. So for the x-intercept, thus y is equal to 0. Take the positive 3 over 5x, and then if you times by 5 on both sides, let me just quickly see, 3x over 5, yeah, you times by 5 on each side, and then you divide by 3 to get x is negative 5. So your coordinate there is negative 5, 0. That's same. Okay. All right, number B says determine the equation of line AB. So if you look at AB over here, it's this one, and we've determined that it cuts through the x-axis there at negative 5. So remember, this is a special line where the equation is just x is equal to negative 5. Now they say determine the equation of line EF. Now EF runs perpendicular, to the equation of the line that was already given. So now, very important, can you see that both of them still cut through positive 3? So your backside must still be plus 3. But now, if they run perpendicular, you take the gradient, you swap it around to make it 5 over 3. And then if it was a positive, you make it a negative. And if you make it a negative, you make it a positive. Just very quick. With 2 lines that are perpendicular, you say the gradient of line 1 times the gradient of line 2 must always give you negative 1. So now, if you've got 2 over 5, what would be perpendicular to that to give you negative 1? If you've got negative 3, what would be perpendicular to that to give you negative 1? If you've got negative a half, just to give you a few examples, times what will give you negative 1. So how do we get the perpendicular gradient? So you swap it around, which is 5 over 2, and a positive becomes a negative. Can you see if you multiply those two, you'll get negative 1. Same over here. Force it into a fraction, swap it around, a third, a negative becomes a positive. Over here, swap it around, which will give you 2 over 1, which is 2, and the negative becomes a positive. So what I need to do is I need to swap the 2 around, and then I add a negative. So it will be negative 5 over 3. And very important, it didn't shift up or down, or you can't choose your y-intercept. It stayed at 3. Then write down an equation of a line that will run perpendicular to line AB. So AB, a line that will run perpendicular to that, will be a horizontal line. And that can be y is equal to anything. Could have been on the negative side, could have been on the positive side. So perpendicular to that, y is equal to, let's say, negative 10. But that could have been any number. Then they say write down an equation of a line that will run parallel to line EF. EF, what will run parallel to that? So we have worked out the line over here. So we have to have the same gradient. So y is equal to negative 5 over 3, because if lines run parallel to each other, it means they've got the same gradient. But the backside I need to change, plus 20, or whatever number you wanted. Okay. Then point of intersection. Calculate the point of intersection of the following two graphs. So always cookie cutter mold. This one I just want to change into negative 4 over 5x plus 9. And the point of intersection is where you equal the two graphs' y values to each other. So a fifth x minus 1 is equal to negative 4 over 5x plus 9. And now if I take this over, a fifth plus 4 over 5 will give you a whole x, and over here 9 plus 1 is 10. So now we've got the 1 point of our point of intersection. We still need the y, the corresponding y value. So you take your x is 10 and you go and replace it into that graph or that graph. Both of them will give you exactly the same answer. So y is equal to a fifth times 10 minus 1. 1 times 10 is 10, divided by 5 is 2 minus 1. So your corresponding y value would be 1. So the point, remember to turn it into the coordinate, point of intersection would be 10, 1. All right, we are almost there. Let's quickly look at this one. Calculate the value of x of the following given graph if the gradient is 2. So always start with your cookie cutter mold. What is your cookie cutter mold for a straight line? Y is equal to mx plus c. But now they tell me that the gradient is 2. So I can go ahead and replace that m with a 2. And how do I find, if you want to, you could have done it two ways. First way is to find the actual equation. So remember x and y, that x and corresponding y value, they sort of like married. That's husband and wife, or wife and wife, or however you want to see it. They always go together. So if you want to find the full equation, especially this y-intercept over there, you'll go and replace a 3, 3, the coordinate 3, 3 into what you've got. And then you'll get 3 is equal to 6 plus c. So c is equal to negative 3. And look, does it make sense? If that's negative 7, that's 3, that could be negative 3? Yes. So your equation is y is equal to 2x minus 3. Oh, sorry. So now you've got your equation. Now you can go and put an x value, the y value in to get the corresponding x value. So you'll get negative 7 is equal to 2x minus 3. Minus 7 plus 3 is negative 4. So x is equal to divided by 2 on each side. X would be negative 2. Does it make sense with the answer that you got? That could be negative 2. Yes, it does. Okay, so there's your answer for x. The other way you could have done it is you could have said change of y over change of x. Okay, So 3 minus 7, just be careful for that double negative, over 3 minus x. So remember, if you start here with your y, so 3 minus 7, you have to go here for the x, 3 minus x. And that gives you 2. And then 3 plus 7 is 10, is equal to 2 times 3 minus x, 6 minus 2x, and then you'll get 4 is equal to negative 2x, thus x is negative 2. Okay, and then the last one. Oh, sorry, my nose. It's so dusty. It's September and it hasn't rained, and it's just lots of hay fever going around. Sorry about that. Okay, so the graph n of x is equal to x is compressed vertically with a factor of a third. So what do we know? We know that in front of the x is a 1. Now it's been compressed to become a third. And the resultant function is given as mx is equal to 2k minus 3 over 3. So very important. This in front of the x is no longer a 1, but it should be a third. So basically, and actually very easy, you equal that to a third, times by 3 on each side, and then you get 2k is equal to 4, thus k should be 2. So if I replace a 2 there with a k, you'll get that it will be a third x. Hope it makes sense. Okay, thank you so much for watching grade 10s. This is a good revision before you go into the exams, especially with function notation, and just remind yourself about all those straight line questions. And yeah, I hope you have a wonderful day further. The next video coming up will be on the parabola, and then I'll explain all the types of questions that you get around the parabola as well. Hope you have a great day. Bye-bye.